Hey everybody, today we are going to talk about the 2-4 Math Excel. So on 2-4 number 1 says make a table of values for the following equation, then graph. So they just want you to fill in these numbers on the right. So you can either do this mathematically and say -3, the absolute value is 3, plus 4 is 7, go through it that way, or on your table you go absolute value x plus 4, then go Control T, and so then you can see all your answers. At -3 it's 7, at -1 it's 5, etc. And remember, if you don't want to just skip over some, you could go to the table settings and change independent to ask so that you only see what they want. -3, -1, 0, 1, 3. So remember, independent to ask if you want it to look perfect like that. And then they ask about the graph, and so that vertex would be at 0, 4, because this is your minimum. It's basically your h comma k. Your h is 0. Your h is basically 0 because there's no horizontal shift. Remember, h means horizontal. And your k is vertical, so emphasize the k. And that was up 4. Remember, the other form of it is y equal ax plus, sorry, I just did this off the top of my head. Y equal a absolute value bx minus c plus d. So that's the other form. This is your vertical shift. This is your b, which affects your horizontal changes. This is also a horizontal change. So the C is the left and right. The B is whether it's a horizontal stretch or a shrink or compression. And then the D would be the vertical shift up or down. And the A is the vertical stretch or compression. Okay, so that's all of the first one. Some of these are going to go quicker. We have the absolute value, x plus 6 means it's left 6, which means -6, 0. And they have some x values picked, and then they want you to put the equal and then whatever. And so again, you can work it their way, or you can use your table, and then the graph looks like that. The next one has absolute value x minus 2 plus 4. So on this one, you're going right 2 and up 4. And just as a reminder, this has both a horizontal change and a vertical change. So this would be 2, 4. Compare this to this one is only vertical change. And this one is only horizontal. Okay, so on this one again, plug in your values. They give you more x's, so you got to put the y's. Now, what they're not showing you on here is the point 2,4, which would be your vertex, and in this case, minimum. So your 5s would match up. Also notice they skipped the 4, which would be a 6. And then your 7s would match up, and so forth. So sometimes when you skip certain values in the table, it won't look completely symmetric. Also, if your vertex was a fraction, for example, then it wouldn't show up in your table unless you do independent to ask. All right. Then this was another one just simply about the table and the graph. It said absolute value x plus 3 minus 1, so that's left 3 down 1, and that's your vertex. And so change your sign. So this was a plus, so it doesn't go right, it really goes left. Okay, that's a lot of the same type problem. Now there's some about graph the equation, then describe the transformation from the parent function, and you're given -5 absolute value of x. So just as notes to myself, it's like, okay, well my vertex is still 0, 0. This negative sign means reflect the x-axis, and that 5 in front is making it more narrow, which is a vertical stretch, because it's a vertical change if it's on the outside. So then in the Math Excel, you say the parent function is stretched vertically and reflected across the x-axis. This one has a -6/5 in front of the absolute value of x. So again, you reflect it, and the parent function is stretched vertically and reflected in the x-axis. The reason why it's a vertical stretch is because 6/5 is greater than 1. So it's more narrow. On this one, it says, without graphing, then identify the vertex, axis of symmetry, and the transformations. So you have the absolute value x plus 4, then -6. So change the sign and make that your vertex, -4. Keep the sign for the y value. Then your axis of symmetry is just the x equal -4. Then the sentence about it is it's translated 4 units to the left and 6 units down. So based on the x plus 4, we went 4 units to the left. And then based on the -6, we went 6 units down. All right, the next one we have negative absolute value x minus 3. So your vertex would be 3, 0, because this time we're going to the right. And your axis of symmetry is x equal 3. And your function is reflected across the x-axis because it's outside, and then it's translated 3 units to the right. Okay, then the next one, write an absolute value equation from the graph. So to me, this is the hardest type problem. The graph gave you -2, -1, and -3, -5, and -1, -5. I just had to look at my graph and see that. And I also noticed it was down, so that means it reflects the x-axis. So now regarding your slope, from the vertex, you count down 4. So you're going from -1 to -5, down 4, and right 1. So that means it's -4 for the right side because that's negative slope, and it's +4 for the right side. So again, that's how you get your -3, -5. And that's also how you get your -1, -5. Now, how it helps to get the slope is, that'd be your vertical stretch amount. So we have a negative for flipping across the x-axis. We have the 4 from the slope, and then we have an x plus 2 because we went left 2, and we have a -1 from going down 1. So this is the equation you have to write. Okay, the next one, number 25. Graph this function and list the x-intercepts and y-intercepts. So you have -2 absolute value x plus 4 again. So your vertex would be -4, 4. You do reflect across the x-axis because it's a negative out front. and then you have a vertical stretch of 2. So this is what your graph looks like. Now, it's asking you what's the x-intercepts and y-intercepts. In this case, there are 2 x-intercepts. From this point, we're going down to right 1. And so that gets you to negative 2, 0. And on this one, you go down to left 2, so that gets you to negative 6, 0. Then your y-intercept is 0, negative 4. So it may help you if you look in your calculator and just look at your values in your table. So again, just use your calculator as needed. Control T, and then I'm going to change my function to be negative 2. Then you have your x plus 4, and then we have plus 4 again. So there's your function, there's your graph, and at negative 2 at 0, and at negative 6 at 0. So that's what I put there. And then the 0 for x, 0 for x means it's negative 4 for y. So these are your answers. So it's asking about the x-intercepts and the y-intercepts. Now the next one is graph 5 halves x minus 3. Now notice you have a value in front. This is like y equal a absolute value bx minus c plus d. Since the b value is not 1, that means the vertex is not 3, 0, since this would be a horizontal compression. Horizontal compression was when b is greater than 1, basically. So what I did was I just looked in my table and I wrote down some good numbers that were easy to work with. I used whole numbers or like something with a half. And then based on that, I graphed it. Now, if you want to be absolutely exact as far as what the vertex is, you take this part, 5 halves x minus 3, add 3 to both sides, and then divide. So it's 3 divided by 5 halves. So think of that as 3 over 1. And you multiply your extremes, and that's 6, and multiply your means, and that's 5. So 6/5, which is 1.2. So this is really 1.2 comma something. But that would not show up in your table. So again, I just picked easy values to work with and got it. Then your description is the parent function is compressed horizontally and shifted to the right. Okay, so then the next one says begin by graphing the absolute value of x, then use transformations of this graph to graph the given equation. So we have the absolute value of x minus 6, and you got a negative sign in front of that. So this is one where you have check boxes, and you have to pick out which ones it really is. So based on this negative sign where it is, it really does reflect across the x-axis, and it's a horizontal shift because it went right 6. Those were the only 2 that you were supposed to do because it's not really a vertical stretch or shrink. That would have to do with the number in front. It's not reflecting across the y-axis because your negative sign would be right there. It's not a vertical shift because that would be the number out here. And it's not a horizontal stretch or shrink because there's no number in front of there. So B is automatically equal to 1. And then I just graphed it. So you need those 2 check boxes and then the graph. Okay, and then the very last one, it's just a graphing problem, so it's not that bad. But what they're doing is they're combining an absolute value graph with a linear graph, because this is like minus 1/3 x. So you're really having a slope of negative 1/3 to this part of it, but you're combining it with an absolute value function. So what I did was I just looked in my table and I picked decent numbers to work with. So I'll do that real quick. Add graph, and then absolute value, 3x, then minus x divided by 3. So there's my graph. Go to my table, and to me, negative 310 was good to work with. Negative 1 was 3 1/3. 0 was 0. 1 is 2 3/3. 2/3, I mean. And 3 is 8. Those just happen to be the points I used, and then I just graphed it. So it's not perfectly symmetric because it's a linear function combined with the absolute value. So there's two different types of functions in this one. Okay, so that would be the end of that that problem. See, this had negative 310, this had positive 38. They're not both 310, negative 310. So it's not perfectly symmetric. All right, again, that'd be the end of the video. Hope that helps.